Okay, thanks for coming to this seminar. I lured some of you in with the word sargassum, and I'm just actually considering sargassum to be a tracer of things, kind of. You'll see as the talk progresses, but can everybody hear me fine? Back row? Yes, hi Lou. All right, my talk is called Sargassum Accumulation in the Caribbean Sea in Response to Anomalous Meteorological and Oceanographic Forcing in the North Atlantic Ocean. And my collaborators so far on this have been Ryan, Nathan, Rick, and Frank Mueller-Cogger from University of South Florida. And let's see, I guess move right along. All right, most of you, I think, probably heard something about the sargassum piling up on the beaches of the Caribbean and everything. Sargassum, as you can see in these photographs, began washing up on the beaches and coastlines of the Caribbean islands, equatorial West Africa, and equatorial Brazil in 2011. The phenomenon recurred in 2014 and 2015. As you can imagine, this caused great economic hardships to the commercial and recreational fishing and diving business. It began to rot on all the beaches. It smells bad. It messes up your boats. Sometimes fishermen couldn't get out to do their thing. Many problems caused by this. So everybody wanted to know what's going on, why is this happening, and how do we stop it, and is it going to keep going? So I decided to look into where did the sargassum come from and why did this happen, with the simple hypothesis that the sargassum came from the only known source of sargassum in the Atlantic Ocean, the Sargasso Sea. But with such a simple hypothesis, even that immediately was controversial because the going hypotheses by people studying this phenomenon were that it could not really be linked to the Sargasso Sea, so it must have been a new growth area blooming in place and recirculating around down in the tropics, and it's going to continue to be a big problem. Now, it turns out that that may not be incompatible with my hypothesis, but let's look at the data and see what we can see. Okay, you can't see the details of this really, but it's just the large-scale wind and current patterns of the North Atlantic Ocean. And ignore the green arrows because I pulled this from a history website, and so that's Columbus's voyage and another historical voyage. However, if you look beyond that, the big blue arrows are the westerlies. Those are the winds that are almost always present there in the North Atlantic, and the red big arrows are the trade winds. We're all familiar with that. This sets up a subtropical gyre circulation, and you see where the Sargasso Sea is over there, just generally in the middle of the circulation, and it sets up a convergence zone due to Ekman forcing, so that things pile up in the middle of the gyre there. This is well-known phenomenon, the Great Pacific Garbage Pile, whatever it is called. There are actually 5 of these convergent gyres in the world ocean. So anyway, that's just the general setup we're talking about. Okay, now this is a wild switch. The Atlantic meridional overturning circulation. Is this a clue? Around the same time I was thinking about this sargassum thing in 2011, it turned out that it was called to my attention that the AMOC, the Atlantic meridional overturning circulation, reached its peak lowest value during 2010, the year before the first Caribbean sargassum inundation event in 2011. And that was a pretty major thing. It was a major low in the AMOC, and could that have been some clue to what happened? Could these two anomalous events be related? So this is, you don't have to look at the details of this, but this is the latest time series from 2004 to 2016 of the transport of the AMOC components and the total AMOC. A number of people here at AOML and across the street are involved with the observational team for AMOC, and most of the rest of us have been to enough seminars and all that we're aware of what's going on. But anyway, the AMOC in purple is computed as the sum of the northward flowing Florida current in blue at the top, the Ekman component of transport in the red, and the geostrophic, mid-ocean geostrophic transport in the green. And now if you're interested in the lows in 2010, beginning and end of 2010, and you can ignore for now the one in 2012 and the big one in March of 2013, you can see that those 3 that I said not to ignore are very correlated visually with very low dips in the Ekman transport. As a matter of fact, the Ekman transport reversed direction. It was such a big anomaly. So instead of pushing things north into the middle of the Sargasso Sea, you would assume that a negative reversed Ekman transport might do the opposite and give another pulse to the south of the Ekman transport. Now you remember how Ekman works. That would mean that for winds that are normally trade winds, say coming into Florida, you would expect a northward Ekman transport. However, near the very surface of the ocean, which is going to become important for this talk, the surface currents align more along the direction of the wind at the very surface, as we will see. So, and the reason we're ignoring the dip in the AMOC in 2012 is because that's obviously happening for other reasons. I suspect the geostrophic term, but others will know more about that. I'm looking strictly at what the wind is doing in the North Atlantic. All right, so another thing you're familiar with, the North Atlantic Oscillation, NAO. Could it be the cause of both the low AMOC and the Caribbean Sargassum inundations? The next slide shows a time series of the NAO index that appears very similar to the Ekman and AMOC transport time series during the period 2004 to 2016. So probably the record NAO events were driving the whole show. We'll examine this concept. This is the monthly NAO index, only showing from 2004 to 2016 to go with the rest of my period that I've been looking at. However, and you can see the low in December 2009, and it was low for several months into 2010, and the record low at the end of 2010. And if you want to look it up somewhere, you'll see that that's the lowest value to the 2010 on record since 1895. So that definitely was a whopper event in the NAO. Note the extremely low values with the index exceeding -4 in December 2009, December 2010, and March 2013. Now, you may recall, if you weren't tracking the NAO, you might have been living in Florida, however, and the winter of 2010 was a whopper of cold winter. Many things happened. Apparently, anecdotally, it was so cold that it was the worst cold water coral mortality that they've seen before in the sanctuary. And also it was just really cold here. I remember having to cover my vegetable garden and everything those nights. And it also, you may have noticed if you were a sailor or a fisherman or something, it was odd in Florida, the trade winds reversed directions. Where did the trade winds go? There were no trade winds that year. So all very interesting and suspicious about this. This graphic I got from Woods Hole, their website. It's a really nice depiction of what the NAO is all about. A negative NAO that we're talking about here today on the right panel causes the westerlies, again red arrows, to move farther south, and the trade winds, the black arrows, to weaken compared to a positive NAO on the left panel. And you can see that, as I was saying, cold temperatures during the negative NAO come flying down towards Florida, and other patterns of sea surface temperature are shifted and all, but I'm not going to go into that part today. Anyway, the biggest point to remember is that the negative NAO causes the westerlies to shift southward into the North Atlantic Ocean. Well, what were the winds like during the 2009, 2010, and 2013 negative NAO events compared to climatology? We can answer this question using monthly wind data from the National Centers for Environmental Prediction, NCEP reanalysis. I think a bunch of you are familiar at least or have actually used the NCEP reanalysis. It's a nice data set that's data assimilating, but the importance of it is for many decades, 50 years or so, they've been running it in the same configuration. So you can compare events and it's easily obtainable. Everybody understands its pros and cons, and it has been able to simulate, as far as I can tell, every kind of significant oceanographic and wind event that has happened. It's really a good kind of data interpolator, I would say. So that's what I chose to use. Okay, up in the upper panel we have the climatological January, February, March winds in meters per second from 2008 to 2015. That's now going to be my averaging period and the period I'll be looking at. It was several years before the event, during it, and after it. And you can see the Sargasso Sea outline there in black. I got that from the Sargasso Sea Commission definition in their literature, just to put for context so you can see what kind of things we're talking about. So that's the climatology on the top, and then you can see the picture is a little different, especially looking at the Sargasso Sea latitude during the January, February, March 2010 event. The southward shifted westerlies, the red vectors between 30 and 40, now extend east of 20 west, which is dramatically different than the either 0 or slightly south and westward vectors in the climatological picture. This is the March 2013 event, climatology on top again, just for all the marches this time. And then you can see what a wind event, this is not an anomaly, this is the actual winds experienced average over the month of March 2013. And it extends across the entire Atlantic between 20 and 40 north, if you can sort of see that. I should have put a box on there, from 80 west to the Mediterranean Sea. So that is really, in a nutshell, the kind of anomaly that this talk is about. You can imagine that floating sargassum in the Sargasso Sea there would definitely move in the direction of the winds rapidly to the east and even run up against Gibraltar and Portugal, Spain, northern Africa. I looked for anecdotal news. I Googled it actually to see whether there were any reports of unusual sargassum pileups in those areas or marine debris in general or plastics or anything, but the 3-minute search failed to turn up any reports of that. So, but it probably happened, not sure. What were the surface currents like during the events compared to climatology? For this, it's a related product to NCEP reanalysis, but it's their GODAS, is that how you pronounce it, model, and it has currents and things at a higher resolution. The wind data were at 2.5 degree resolution, and the current data are at, I believe, 1 degree in longitudes and 1/3 of a degree in latitude boxes. So anyway, they're very compatible too because this model for the currents feeds in from the data in the NCEP reanalysis. So now we've got the beauty of all this for me was it was easy for me to work with. It's an X, Y, Z, T data set gridded, and it's all internally consistent, and you don't have to patch things together or do interpolation of various things. You just use it. All right, you can't probably see directions very well. I'm going to find a different way to show these currents. The problem here, I suppose I tried to make up a kind of a scale that would show it. The currents are so strong and fast down in the tropics and so small but yet significant up in the northern part that it's hard to see what's happening. But trust me, that's a gyre flow and a subtropical gyre. That's the typical JFM surface currents. And then down here, it's during the January, February, March 2010 anomaly. And if you can force your eye to follow the yellows and greens all the way across out of the northern Sargasso Sea and into the eastern Atlantic, you'll see that there is a difference. And I'll have a better way to show that quantitatively in a few slides. But so anyway, okay, it did cause, you'll have to see later too because you can't see the arrows here, but it caused strong eastward flow and with a southern component also, which would have helped across the whole Sargasso Sea basically, would have potentially helped sargassum to drop out of the southern side of the Sargasso into the Caribbean currents more than it usually does also. Normally, as you recall, it's a convergent area. Same thing for the March again. And again, it's really a whopper. Look at those eastward currents in the March 2013 map. It's a big, wide swath of stronger, different direction currents that you see. Now I want you to mentally imagine a box between 20 and 40 north and from 80, Florida coast basically, over to 10, basically Gibraltar and along the coast of Africa, because now we're going to do some averaging of these numbers and look at the time series. I think that's what we're going to do next. When I push this button, I'll know. Yes, we are. Okay, these are the NCEP monthly winds. All the data that I used, by the way, were the monthly. You can also get it daily, weekly, everything. But for such a big phenomenon as I'm looking at, monthly data has been just fine, and it provides a natural sort of smoothing and averaging that was desirable. Okay, the climatology, I have two different vertical scales. So for the scale on the left, the climatology, for 2008 to 2015, and the actual monthly winds are shown. And as I think you'll notice, those same three peaks, we're getting used to looking where they are. December of 2009 into January, February, March of 2010. And then again, it's a phenomenon. When the NAO does this, it's called recurrence. It's been written up about in the literature. It's simply that the increased cold temperatures, when the summer months come along, the NAO tends to have its lows in the winter. When the summer months come along and warm everything up, you don't see it as much, but the cold water is still there underneath the surface. And as soon as you get stirring again, you can have a sudden recurrence. It often happens this way. I gather that it's hard to predict the first low peak, but you can often start to predict the second one. But it doesn't always happen, and it's not exact. So anyway, and the anomaly just makes it even more. I didn't probably even need the anomaly there. I think it's abundantly clear in the top panel that in terms of the NCEP U component of winds, this was a big deal. You can see that, except for those three peaks, the average is actually the other way, of course, as we knew. Well, we didn't know for average over the whole box, but it is. And then those peaks reverse the direction of the wind. These are the NCEP currents that go along with it, and it's the same idea and the same phenomena. Eastward, strong eastward anomalous currents as well as winds. Okay, then we move on to data from AOML's Global Drifter Center. We're also used in the analysis to examine how surface flotsam might respond to wind and ocean current forcing. These drifters are deployed globally and are tracked by satellite for periods of up to several years duration. Many thanks are due to AOML's Global Drifter Center for their drifter data used in this study, including Rick has helped me out consulting and all with certain aspects of this. You'll see in a minute. Okay, what can we learn from satellite tracked surface drifter data about Sargassum? Surface drifters that have lost their drogues are likely to behave very much like floating Sargassum. That's kind of another hypothesis right there, but it strikes me that if you wanted to try to find something to look at that you can use, data you can use, it would seem like a drogue that lost its drifter might behave quite a bit like Sargassum that tends to float near the surface, a little bit out and more underneath, and it's probably not an exact match in terms of each thing that floats. Probably a styrofoam cup moves differently than an iceberg or something under the water. But I'm going to take the standpoint that drogue-off surface drifters can tell us about something about the wind anomalies and their effects on the currents. All right, first of all, we'll just show a few anecdotal individual trajectories. There are many, many of these. I just picked a few just to have a few points to say about them. This particular drifter illustrated nicely what we were looking at in the wind fields. Deployed in April 2007 in the northern Sargasso Sea. It stayed in that, I know it's not in the oval, but we'll talk about that a little bit later, but I think the Sargasso Sea, or at least the gyre, is bigger than that oval. But anyway, so it moved very slowly and meandered around and didn't really get anywhere until December 2009. You'll have to trust me on this, it's in the data, when suddenly it took that direct course to the east. And then it moved rapidly for several months at quite a clip. I don't have the number with me right now, but it was rapid. Until April 2010, and then it got out of that and took the normal, if you recall when I mentioned that there's a southward winds along Africa, and then got into the trade winds, and it moved rapidly then and arrived and grounded in the Caribbean near St. Kitts and Nevis in November 2010, just before the first major Sargassum inundation was reported. So this doesn't prove that it happened, but it certainly provides an example of, this was a drogue-off drifter for most of its life, and it's an example of how such a thing could have happened.
When did it lose its drogue?
Very early on. I have the date in my notes, but most of what you see here was drogue off. These drifters were all deployed in February, March 2010 near the coast of Africa at around 16 north. I was unable to find any drifters that lived long enough or happened to do the thing where they made it over from the Sargasso Sea and then down into this African circulation. There may be some, or I was going to talk to Rick about some of the games he can play in his talks where you could patch together drifters that died in the vicinity of where you wish you had, and then find a buddy for that drifter that carries on at the same time and place. And I'd like to play some of those games with it. But the point being here that it demonstrates a possible pathway for Sargassum to have entered into the equatorial current system. We know that the Sargassum could have gotten over to Gibraltar in northern Africa. We know there's a strong southward wind and current there, ever present as far as I could tell in all the data that I looked at. And then those played around in the east-west tropical circulation there until eventually they ended up, this is my hypothesis kind of, that ended up and grounded there in Africa. However, they could just as easily, and there are many, many pathways where they could have gotten caught up in then a westward current again, very close by the vicinity, and could have grounded in Brazil. And as a matter of fact, I don't have an example of that southern route there, but this one, yes, the other, there's lots of evidence that things could make it over there into the mouth of the Amazon River area near the equator. And once anything makes it there, eventually it's a seasonally changing circulation, but it either in the spring into the summer goes directly into the southern Caribbean, or the other times of the year there's a strong retroflexion of the North Brazil current and it shoots back out over to Africa again. And furthermore, the North Brazil current sheds rings, which could be another potential slower moving transport pathway into the Caribbean for substances that found themselves in that area. And just one more little drifter trajectory. This one was sort of cute, I thought, because it was single-minded there. It was deployed at 16 north off the coast of Africa. There must have been a big deployment burst there of some project because lots of them were deployed at 16 north off Africa at that time period. It took a nearly straight path along 15 north approximately until entering the Caribbean in November 2010 and dying in late January 2011. It doesn't seem to have grounded anywhere. I don't believe there's an island right there, but that's just what happened. So if it could do that, then particles of anything else could also. And if I can develop a more easy to do way to assimilate all the drifter data and search for certain things, that would probably become more clear. So those are the trajectories. Is there another way to look at this phenomenon using the drifter data? Well, we can look at maps of the average weekly number of drogued versus undrogued drifters at any given time in 5-degree lat by 5-degree long boxes in the North Atlantic. Their spatial patterns should mimic the movement of floating patches of sargassum, and we can also examine the average velocity of the drogued versus undrogued drifters on the same time and space grid. And my thanks go to Rick for having pulled out and made this file for me. I didn't have a way I could really think of doing myself to separate out drogued and undrogued and all, and he just generated this gridded file for me that really has fascinating, still more potential to come of what we can do with that. So. Okay, this was surprising to me that it was so neat and clean, but this is the map of the average number of undrogued drifters for 2008 through 2015, the whole thing. And as you can see, and the scale is on the right, it's 0 to 5. And it clearly shows the large convergence zone located within the North Atlantic subtropical gyre. And this picture does not change significantly on a seasonal basis. If you divide it up into quarters or anything like that, that's what it looks like. Now, in any individual year, it can be different, or, you know, but this shows you what the oval might have wanted to have looked like instead of the oval that it is. That's where all the stuff piles up in the red area. Then this is a similar analysis, but for January, February, March 2010. The wind anomaly that began in December 2009 appears to have disrupted the climatological pattern and blew the undrogued drifters rapidly to the east, all the way to Gibraltar. Some also seem to have escaped the gyre to the south. Now, single pictures like this, I have actually personally looked at all of the maps and everything because I wanted to rule out just natural variability, or somebody went and deployed a bunch of drifters over in Gibraltar just when I didn't want them to, or something, you know. But I think that this is likely to be what happens, and I'll comment in a minute on that. And then these are the 4 quarters of 2010, watching it as it developed after the anomaly. From January, February, March 2010, April, May, June, it has continued, and I don't know what this data is just a little bit noisy too, because drifters are great, but they're not everywhere all the time. So, and then you can see that some of the undrogued drifters seem to have made their way into the tropical circulation, into the north equatorial countercurrent, and even have a blob now along the coast of Africa. This is circumstantial evidence here, but it looks as if the scene is set for the Sargassum events of 2011 and 2014-15, given the similar forcing in March 2013. That must say not shown. I said it before. But. All right, here's another way you can take the same data and look at something. These are now maps of the U component of the velocity from the undrogued drifter data set. We've got January, February, March climatology in the upper, and we've got, it's kind of washed out here, the anomaly months, January, February, March 2010. And if you look closely, you can see, not probably, that it's pale green up there in the climatology, meaning westward flow, but that it's all low flow to the east, to the west, no, to the east there in the second panel. I have another way to show this. And this was the March anomaly, as you can see. That's not even the anomaly, it's the winds during, I mean, it's the currents during March 2013, the U velocity from the undrogued drifters. And that's a bigger, more noticeable signal right there. Keep in mind still that same box we used before to make time series, 20 to 40 north and 80 to 10 west. And there are the time series. Now this is completely independent of the NCEP reanalysis and GODAS currents. This is now drifters bend into 5 degree by 5 degree squares and weekly averages of their velocity, as opposed to that product that does not assimilate drifter data. So you can see the familiar, abundantly see the December 2009 and the first 3 months of 2010, and then again late 2010, and the March 2013 event is popping up very nicely in the drifter data. So, and then if you look at the drogued drifter data in the bottom panel, most of the same peaks show up, not all of them, however. There are other things affecting a drogued drifter, other geostrophic flows and things. But if you look at the peak, the highest peak there, I pulled out some numbers for it. The eastward maximum undrogued is 0.11 meters per second for the undrogued drifters and 0.09 for the drogued drifters. And the difference is 0.02 meters per second. And this would have been expected if you consider that the drogued drifter is grabbing a thicker chunk of the water column. And these are the V components of the two. Undrogued up in the top there, you can see that those little southward pulses that showed up in the NCEP reanalysis data are there. And they're also there for the most part in the drogued drifters. The southward current would have a tendency also to bring everything that's happening in these anomalies would have a tendency to blow the Sargassum to the east or to the south, out of where it almost always is located in great abundance. I also did a few back of the envelope calculations to look and see directions also of this, and it worked out quite nicely with the drogued ones having a slight right bias to the angle that the surface at the very surface undrogued seems to be going with the wind. So that supports that kind of idea we were following. Okay, we come to hypothesis number 2. Will the Sargassum accumulations continue to occur? Is this the new normal? There was a great deal of concern down in the Caribbean nations and Africa and Brazil about this. It was really ruining everything for them, tourism, fishing, everything. And they needed to know what to do. I mean, do they need to buy a lot of bulldozers? Does somebody need to figure out if you can eat Sargassum? Can you use it as fertilizer? There's this message board of Sargassum people from the whole area that's just very active and lively. And the topic was so hot, really, that the Gulf and Caribbean Fisheries Institute held a whole special session on nothing but the Sargassum events. And so I requested whether I could travel and go, and I could, it turned out. And so I gave a talk on this stuff there and met the other people who are working in this area. Still, my hypothesis was, somewhat counter to the other ones, but we all got together and talked about it and decided that hypothesis number 1, that it came from the Sargasso, it probably did, that is true. And then once it got into the tropics and equatorial regions, there are different conditions there, better sunlight, more nutrients, things like that. A lot of the old studies on sargassum growth demonstrate very clearly that sargassum will flourish in conditions like that. It's nutrient limited. Others here in the room know more about that than I do, but it grows better, it grows faster, it grows bigger leaves and berries, and it must have been extremely happy to have found itself in a new environment that it had never been before. But the sad hypothesis number 2 is my hypothesis. The sargassum accumulations in the equatorial Atlantic will eventually be self-limiting due to the divergent nature of the large-scale winds and currents in the tropical equatorial North Atlantic. We talked about the Ekman being a convergence region in the subtropical gyre. Well, it's exactly the opposite with the setup of the east-west winds in the tropics and equatorial regions. So for 2 reasons, it's divergent. Both the Ekman is not going to converge anything. It's not going to, and sargassum isn't holding on to anything. It's not anchored. It's going to go. And plus just the nature of the strong east-west currents, as I'll show you in a second here. Okay, this is from Rick's group again. The annual mean drifter speed in centimeters per second. Note the very strong equatorial and western boundary currents in the tropical Atlantic and the Gulf Stream in red, focus only on the Atlantic for this, and the very weak or nearly absent currents in the North and South Atlantic subtropical gyres. Most things that would get caught up in this circulation, floating things, would definitely, drifters included, just rapidly leave the area and go where the strong currents go. So that's a reason to expect that sargassum is not going to grow there now as a new area where it's flourishing and happy. It may be transiently passing through, and I have a suspicion that an area that they've been seeing as a blooming area just to the east of Barbados, a big area there, is probably more related to the North Brazil current rings accumulating it and slowly moving things by, and would make it look from space very much like a region of increased. So we definitely have the data to look into those kinds of things here, and it probably should be looked into. And finally, we'll be done well in time. This is another product that they put out every week from the Global Drifter Center, and I just happened to pick one right before I went to that meeting in the Caymans. And it is a typical map of the status of the Global Drifter Array for the week of October 24th, 2016. Areas of convergence, accumulation, which includes drifters, both drogued and undrogued. I forget which is which, red or blue, but. And areas of divergence, rapid dispersal, are easily seen in these maps. You can see that as the equatorial band of very few drifters. That's not for lack of trying. I understand anecdotally from these guys, Rick can confirm this or deny it, but it's hard to keep an even distribution, hard to keep drifters in those areas because they go out on the strong currents and they get expelled by the Ekman. So it's an effort. If it's an effort for the Global Drifter Center to keep drifters there in great enough quantity, it's probably difficult for sargassum to hang out no matter how good the nutrients and sunlight may be there. All right, summary and conclusions. There was an unprecedented accumulation of sargassum during 2011, 2014, and 2015 on the beaches of the Caribbean Sea, equatorial West Africa, and equatorial Brazil. That actually was part of this whole, why the project seems so interesting, because that was definitely not random if you know about the currents down there. The fact that Africa and Brazil and the Caribbean are connected comes as no surprise. This was likely due to anomalous eastward winds and currents triggered by record lows in the NAO during 2010 and 2013. Each time that's the year before, because it takes about that long. We can get that from drifter trajectories to make that distance and get to where it's going. Caused the sargassum to exit the Sargasso Sea and drift rapidly to the east, after which it was able to drift south to Africa and west into the tropical Atlantic, coastal Brazil, and into the Caribbean Sea with the prevailing seasonal trade winds and currents. In other words, I don't know if I made this point well enough, but the anomaly was all the westerlies coming down into the northern part of the Atlantic there. The rest of it didn't require an anomaly at all. It just required, and the currents weren't anomalous, and the winds weren't anomalous during those periods of time. It simply required one event, blow it all out to the east near Gibraltar there, and then let the circulation take its course. And I believe that could have easily done this. I wish that I had some tagged Sargassum or something, but I didn't. So hypothesis number one, that the Sargassum did in fact originate in the Sargasso Sea, is supported by data from the NCEP reanalysis model and the Global Drifter Program. As I said, both completely independent of each other. It's fun to be looking at a very large anomaly because you can usually find it in everything. Probably it affected bird migration timings and coral reef health, as we know, and other things. Okay, hypothesis number two, that the Sargassum inundations will be self-limiting due to the divergent nature of the large-scale winds and currents in the tropical North Atlantic Ocean, remains to be proven with time. However, anecdotal reports from 2016 were like, where's the Sargassum? It's not happening this year. People on sailing, charter sailboat places have little forums. I'm reading all their blogs, and the tourists and the hotels and everybody. It simply wasn't a problem in 2016. So I didn't know how rapidly I thought it was going to clear out of there. We could do studies with models or HICOM or something like that to see what the clearing time would have been. But it's interesting, and it certainly doesn't disprove my hypothesis number two, that there was not a Sargassum event in 2016. All right, now this next one, I hope that you can add some, these are not so much future work, I suppose, as just ways to go beyond this. I think I'm pretty much going to go ahead and write this work up so far, but future work would be to do a more in-depth study of the NCEP reanalysis and the drifter data sets to examine all of the possible dynamical pathways for Sargassum to have reached the areas experiencing the coastal accumulations during 2011 and 2014-15. There's much more you could do with the data set, both data sets, the drifter and the NCEP. You could make movies, for example. All kinds of things might help to illuminate what's really going on, and some smart people may want to give that a try. We will compare these results with the new satellite ocean color-based observations of floating Sargassum mats that are being developed for prediction of Sargassum presence and movement. Especially a colleague of mine, Xuan-Min Hu, up at University of South Florida, is coming along very well with being able to use something about the ocean color data to separate it out and pinpoint Sargassum, and then be able to quantify that and make maps and do statistics on it. And so I'm kind of excited to get a draft of this together and send it up to him, because I think he might have some ideas how we could improve it. We would like to use the HICOM model to perform forward and backtracking experiments to better connect the Sargasso Sea with the Sargassum grounding zones in Africa, Brazil, and the Caribbean. I actually did a similar analysis to that with the drifter data, just the regular drifter data. I made little boxes and required drifters to go through my little box off Africa where the landings had been, off Brazil, then the entire Eastern Caribbean, a very narrow rectangle through the islands, and then the Northern Caribbean. And that was great. That's how I got my representative trajectories, for one thing, because there's so much drifter data that you just have to have a way to narrow it down. And so I looked at where those drifters had been that had been in the area when the Sargassum was grounding. It was very illuminating. A lot of them come from the South Atlantic, as we know, but quite a few of them come from areas of the North Atlantic also. It just seems as if drifters don't really, in general, live long enough to show that they're a member of the Sargasso Sea community who then leave and go to all these other places. I didn't find individuals who were doing that, but I think the smoking gun is sort of there. And HICOM would be perfect. Nathan has been talking to me a little bit about the HICOM model, because he uses it to study turtle movements and all kinds of things. You can do forward in time and backward in time. It blows away the NCEP reanalysis monthly data and the drifter data too, because now you have data everywhere all the time and you can see what it's doing. And then finally, we hope to provide an alternative method for advanced prediction of similar events based on near real-time observations of large-scale North Atlantic wind and current anomalies. This one's in there because that's really what the whole question that the Caribbean nations were asking, and they were asking NOAA, and so NOAA was asking us, is there a way that we can predict what's going to happen? This blindsided all of them down there in 2011, and is there some way we can tell? And I think that based on available near real-time observations of wind and currents, I might be able to say, well, and also we don't know yet how long is it going to take to pile back up in the Sargasso Sea to the big levels that are normal up there. But once it does, then maybe we would be able to see a big dip in the NAO and say, oh, that's going to make the westerlies move south, and probably you're going to get another Sargasso event next year, something like that. We could play some games like that. But this is the part where so many people in the room, it would be very nice if somebody could give me some suggestions of what we might do more. And thank you for your attention. Are there any questions? Yes. Thank you.
So then, it seems that the NAO is a good predictor of those events. So were you able to go further back in time?
Well, they've never reported any event like this before. I'm sure it did happen when the NAO was low, but Sargassum never piled up in the Caribbean before, according to what everyone was able to say and find. Yes. Yep. You should see the news articles and everything. Long-time resident. I just love events like this. You might remember that we wrote up a paper about a strange green water plume that was from a North Brazil current ring that affected all of the Virgin Islands and area for several months in 2009, I think it was. Again, they were saying, no, people had lived there just for 50 plus years. They'd never seen anything like the pea soup water and ruining the fishing and diving and said, well, this is just like happening again, but it's Sargassum this time. So, but yes, I think that you probably could predict such events now, but why in the past? However, remember, this is the lowest NAO value that's ever since 1895 been experienced. So maybe it was just a whopper. It would be fun to just compare in the data set all the times and see what. I didn't go back farther than 2008 because, believe me, that was plenty of data for me to look through. I don't use supercomputers and things. So. But yeah, that would be interesting. Let's go here and then Lou.
Oh, hi. Thanks for that great talk.
Oh, thank you.
And it's expanded a lot since I saw the pre-talk talk.
Mm-hmm.
So
the pre-pre, and then there was the informal, and then there was.
It's wonderful the way you kind of brought together some of what I guess people thought they knew about the sources for the Sargassum off the coast of Africa with your hypothesis. Going back to Matthew's question, in terms of looking forward, giving some sense of how predictable these events might be. Looking at the I know the NSEP reanalysis goes back to the 19.
The winds go back quite a bit farther, and the currents go back to 1979. So, yeah. But of course, there are other more sophisticated, I'm sure, products out there to use too. So maybe just pulling in another colleague.
Baseline is really useful if there are periods where the anomalies looked like they did in January through March of 2010, and there were no reported inundations. That gives you some uncertainty.
Right.
Ecological forecast, and that's definitely something that Dr. Hindi, I apologizes he couldn't be here.
Oh, that's okay.
That's definitely something that his group is interested in.
Oh, I know. Yeah, we've talked a little bit too, and you, I know, are. And we actually, then I'll get to your question. A group of us, including Gustavo and Lou and Nathan and I, and maybe I'm forgetting somebody, we actually do have a proposal in to NASA that we're just waiting for the, review and approval process. But it's to follow up this work by looking more rigorously at various things, such as exactly how does Sargassum move with the wind and the water specifically. Maybe some tracking experiments and things like that are definitely in there, and more HICOM types of things. And then Xuanmin is also with that group of us with that proposal in. So I would love to combine now. I just didn't want to contact him before because I didn't really think all my ducks were in a row as to what I thought happened to bother him about it. But now I think I'm ready to bother Xuanmin about looking at some large-scale satellite products for this. But Claudia, did you?
Yeah, no, I'm curious. We had a lot of sargassum in Florida as well. Is that going through the Gulf of Mexico and the Loop Current and everything?
Yeah, so that happens every year anyway. If there had been anybody from the Gulf of Mexico here, they would have pointed out, I forgot to mention that the Sargasso Sea is not the only place that you see sargassum in the whole system. You definitely get it in the Gulf of Mexico also, and at beaches up near Galveston and everything. And actually, I did look at drifters in that little box too, and it was illuminating. But there's a controversy, but most of the literature comes in on the side that it's growing, and the source is the Sargasso Sea, and then it does come through the Windward Passage and Mona Passage. It forms part of the whole loop. It beaches because of loop current rings, but the reason that they think that that's more of an end point, some of it then does continue on, but it's an end point because the Sargassum is older and less well in the Gulf than it is in the Sargasso Sea and along the U.S. East Coast. I think Sargassum may live several years, any individual group of it, if anybody knows better, please let me know. But it encrusts itself. Yeah, Sargassum is also fascinating. One little anecdotal thing, on one of my first ever oceanographic cruises off Cape Hatteras in the Gulf Stream, we were thrilled about the Sargassum. We actually made a little flow-through big tank with salt water flowing through, and we checked out the Sargassum. And if you aren't familiar with Sargassum, it's fascinating because it's got a whole little ecosystem. Tiny little Sargassum fish that look like Sargassum, same color, everything. Little Sargassum shrimp. Everybody looks like Sargassum. And so each piece of Sargassum is a whole world, a microcosm to everybody. So, but anyway, when Sargassum ages and ages, things encrust upon it, and it gets heavier and heavier, and now it's sinking below the surface of the water, and it's not doing as well. It doesn't have as much sunlight and everything, and so it ends up in the Gulf of Mexico. So I think that those who say that the Gulf is not the source of the Sargassum are probably correct. That's like an end. What joke did I miss in the back row here? Yeah, right. people go right. So anyway, if anybody can think of a way to improve my story in the next few weeks here, or something I should try, Matthew, good.
Going back to NAO, do we have an idea on climate projection of if there would be more intense peak of negative NAO in the future or not?
Well, I understand from a source that I discuss this with from time to time that it's very difficult to predict the NAO. Professor Johns, do you have any words to add here?
Well, it is. I mean, it's a natural mode of the atmosphere, but, global warming, all of the atmosphere is more energetic, so I think most people believe the NAO is going to be more energetic. So, it's probably likely. I mean, it would not be as surprising if that happened.
Okay. And one last thing that reminded me of, I also looked into, you may be wondering, what about the other climate indices and everything? Why are you looking at just the NAO? Well, I did look at all of them. The NAO was the big, obvious culprit here. However, there are a number of other indices that are of interest. And so the Atlantic meridional mode, there's an East Atlantic mode that's very interesting. These are in sea surface temperatures and pressures, and they cause changes to winds and currents. None of them, I believe, cause this phenomenon, but each one of them rang the bell from the literature in either the positive or negative sense that would have promoted this change in route and everything, and the theory, instead of taking away from it. So I actually had some vision of making a Sargassum index, a Caribbean, it was going to be CSI, Caribbean Sargassum Index, but I really came to the conclusion, and I played some games with the time series and everything, I really didn't think it was going to be all like, smoke and mirrors, because it was the NAO, and whether or not, I don't think it would have added anything or taken anything away to add a small signal from ENSO or this or that, but they were all, trust me, in the right direction. So, bye, Lou. All right, is that all the questions? Oh, we got another.
You mentioned that the Sargassum may be in another region when it's out of the Sargasso Sea, being favored by the condition, nutrient condition, right?
That's what people all think, and I agree, yeah.
Is Sargassum nitrogen limited in the...
I forget right this second. The person who's been studying a lot of this over many decades is Brian LaPointe, and he was at the meeting also in Cayman Islands. And it is limited, and I wish I could tell you if it's nitrogen or phosphate, because that's not my thing, and I should remember that. I can tell you afterwards. I have the papers. It's definitely limited, and it's definitely would be expected. They've done this in tank experiments, and then if you took a bunch of live, healthy Sargassum and put it from the Sargasso Sea, which is low nutrients, oligotrophic, put it down. Oh, there's also a little mystery. Why does it do so well there too? But, it gets enough, I guess. Put it down in the tropics. It's definitely going to be like a little tank experiment. It'll be very happy. The problem is it's not going to be allowed to stay very long, I think. So, and plus things, you can see maps of where drifters are ground and other things. There's a lot of grounding of a lot of stuff in the whole Brazil coast, Africa coast, and the whole Caribbean. As a matter of fact, every time we go out on our cruises to the Caribbean and we deploy drifters, we're very happy if one lasts, to get out of the area. A lot of them do show very interesting trajectories, but some of them, as you know, just kind of head over to St. Kitts or somewhere. But anyway, that's the story, and thank you very much for coming.